All right, welcome everyone. Thank you for joining us to today's presentation. My name is Megan Balding and I'm with the USC Viterbi School of Engineering. And it's my pleasure to welcome you today to our Spotlight series. Today we'll be focusing on master's programs in cybersecurity engineering and data science. I'm joined today by a few panelists, and I'd like to just take a quick minute to introduce them. I'll be doing a bit more of a formal introduction within the presentation itself. But before I get started, I just wanted to thank Professor Yolanda Gill and Professor Clifford Newman for joining us today. Professor Gill is the Director for the Data Science Program within Computer Science, and Professor Clifford Newman is the Director for the Cybersecurity Engineering Program here within USC Viterbi. And so they will be speaking directly to these programs shortly within the presentation today. I'm also joined today by my colleague, Erin Tanaka. Erin will be handling questions as they come through the Q&A. We will be leaving those questions that are a bit more general that can be answered by the panelists towards the end of the presentation today so that everyone can hear them, and we'll give our faculty an opportunity to speak directly to those questions. Beyond that, we will get started. So in terms of some housekeeping items, we will be sending out a copy of the slides after the presentation today. So there's a lot of really great information provided to you. So those of you attending today's sessions will receive a copy of the slides following the presentation. Additionally, we highly encourage you to ask questions throughout the information session today. Please do utilize the Q&A panel, as that's how we'll be able to best monitor all the questions coming in. In terms of today's program, I will quickly provide an introduction to the University of Southern California and the Viterbi School of Engineering. But then at that point, I'll be passing the presentation over to our panelists today to provide a much more detailed program overview of both the data science programs as well as the MS in cybersecurity engineering. And that will be the focus of today's presentation. Once they've completed their overview, I will then present quickly on Dena Viterbi, which is our online delivery option, a quick overview of tuition and fee information, and then we'll leave the remainder of today's presentation open to you, the attendees, to ask any questions that you may have on the programs that we are presenting on today. If you've never visited the University of Southern California, these are some images throughout our campus. We are the oldest private university in the Western United States, founded in 1880. We have just over 47,000 students and about 4,400 full-time faculty members. We have a diverse student population with students coming from all 50 states and over 100 countries. And the campus itself is located in Los Angeles, just a few minutes south of downtown LA. In terms of our academic departments, within the Viterbi School of Engineering, we have 8 academic departments, 191 tenure-track faculty, of whom 16 of our full-time tenure-track faculty are members of the National Academy of Engineering. We have over 70 National Science Foundation Career, National, and Presidential Young Investigator Award winners. We do have a student population within the Viterbi School of Engineering of over 2,800 undergraduate students and just under 6,200 graduate students. Our graduate students consist of both our master's and doctoral student population. In terms of our research, we are considered a leader in funded research, and I actually have some additional information on that in a few slides. If you're not familiar with U.S. News & World Report, they do provide annual rankings in a variety of different areas. USC Viterbi is consistently a top 10 ranked graduate engineering program overall. Additionally, when looking at our online programs, we are consistently the #1 ranked online graduate computer information technology program for our MS in computer science. And additionally, a top ranked program over all 40 of our graduate engineering programs that are available online. And I already see some great questions coming in through the Q&A. Please note that we will be addressing these specifically in the Q&A session at the end of today's presentation. So don't think that I'm ignoring you. Please continue to send over those questions, and then we'll moderate them at the end of the session. In terms of the USC Engineering School, we have a strong international reputation for excellence. Much of that has to do with the amazing work that our Trojan Family Network, our network of alumni, complete while after completing their programs here at the Viterbi School. We have over 77,000 engineering alumni located throughout the world. And then within the programs available on USU's campus and within the Viterbi School of Engineering, we do have program offerings available online, on site through our continuing education and executive education offerings, and of course through our traditional on-campus program offerings. We offer a complete range of programs at the doctoral, master's, and bachelor's level. We have graduate certificates in a number of areas, and these are about half the units of a master's degree. And then we also offer short courses and customized programming that falls within our executive and education realm. Today's presentation will be focusing on our master's level programs, and we'll be getting into those shortly. As I mentioned, the Viterbi School of Engineering is considered a leader in research, both within the University of Southern California and amongst its academic peers throughout the U.S. and the world. We have a highly interdisciplinary research environment with diverse research areas, including artificial intelligence, robotics, software engineering. I could go on and on about all of the research that's being completed here within a number of our research centers, including the Information Sciences Institute, which is located in Marina del Rey. If you are interested in learning a little bit more about the research areas within the Viterbi School, I encourage you to visit our website, viterbischool.usc.edu. We do have a search function, a research search function, so if there's specific areas that you're interested in learning more about, I encourage you to visit that site for more information and to search within our areas of specialty. We have over 35 research centers housed within the Viterbi School of Engineering, and much of our research has to do with industrial partnerships and collaboration. So today, I would like to quickly introduce you to our faculty directors, and specifically to two of the faculty that will be speaking to our program offerings in more detail. First, Professor Yolanda Gill is, as I mentioned earlier, the director for the data science program in computer science. She'll be speaking to the data science programs that we do have available at the master's level, including our interdisciplinary programs within data science and also our applied data science program. She is also the director for the Center for Knowledge-Powered Interdisciplinary Data Science. She is a research professor of computer science and spatial sciences, and a principal scientist at USU's Information Sciences Institute. Professor Emilio Ferreira is our associate director for the data science program in computer science. He is the director specifically for the applied data science program. So as you're going through the presentation today, if there are specific questions that do come up to applied data science that we're unable to answer on the session, we can make sure that he's able to answer those at a later point. Additionally, Professor Clifford Newman has joined us today. He is the director for the Cybersecurity Engineering program here at USC Viterbi and is an associate professor of computer science practice. Both Professor Gill and Professor Newman will be joining us today to speak directly to these programs, and it is my pleasure to welcome you both and to thank you sincerely for coming today to speak to these programs and provide a little bit more information about these areas to our audience of prospective students. So Professor Gill, I'll leave the presentation over to you at this point, and thank you again for joining us.
Thank you very much, Megan. I'm very excited to tell you about our data science programs. These are very unique career opportunities that result from having data science degrees, very sought after in the marketplace. So I want to tell you what is data science and why it's interesting and important and what we have to offer at USC. So on the left of this slide, you see computer science. So in computer science, we teach a lot of algorithms, the deep technicalities of computing. On the very right at the top, you see different areas of study. So whether you study marketing or political science, you start to run into data. So Twitter, for example, gives great data sets to study political science and unrest, civil unrest, and trends for marketing. Twitter also gives you a lot of data about customers, etc. So when you start to have data, you start to think about computing. And so what you see in the middle of the slide is that there's a discipline that is emerging of data science where you're taking technologies from computing to focus on the mining of the data. So within computing, there's a lot of aspects, for example, user interfaces and other things. And here we're really emphasizing anything that has to do with data. And then there's interdisciplinary data science, which really bridges an area of study with data science. So for example, what are good techniques to mine social media for advertising, for example. And so at USC, we have programs both in data science and interdisciplinary data science. And as you move to the right, computer science is more and more applied and customized to a discipline. And as you come towards the left, we articulate better what are the deep questions and the areas of research that we need to put forward in computing. And so you get basic computer science skills when you study data science, and then you learn how to build data systems at scale. So how do you learn data science? When you are analyzing data, there's many aspects. So you can see in red some of the highlights. You will study mathematical foundations of statistics and data. You will learn computational thinking, how to solve problems using computing algorithms, statistics, managing data, where to store it, how to collect it, etc., how to describe your data, how to model the content of your files and how to relate data from different sources, how to talk about your data, communicate results and findings from the data, how to reproduce the analysis that you did last month so that you can include more data, and also many ethical aspects of being responsible with the data, respecting privacy, and so on. And the quote here is from the National Academy of Sciences, and they talk about all of these skills, and they talk that adding to that, there is something called data acumen, which is what allows you to really make good judgments and good decisions with data. So there's something to be said about learning not just the technical skills, but the practical skills, the ethical skills of using data. The diagram that you see at the bottom shows how people typically describe data science. So it's an intersection between mathematics and statistics, computing, and then other disciplines, whether it be communications or environmental studies and so on. And so the intersection is data science. But I can tell you as a computer scientist that where I see the most innovation and the most new things that are empowering data science come from computing, both in the AI and machine learning and also in the scalable distributed computing side. So our data science programs are listed here in the middle of the slide. We have a master's in applied data science, and it falls in this category of very concentrated computer science knowledge concentrated on data science. We have bachelor's degrees, but I won't get into that. And then we have a range of interdisciplinary data science degrees that I will also mention in the presentation. If you have a strong computer science background and you're interested in a little bit of data science, but general computing skills, you can take a master's in computer science with a concentration in data science or a master's in machine learning, as you see on the left side. If you have just an interest in one particular discipline and you don't want to learn the general computing skills, then you can see some programs on the right side, for example, digital social media or neuroimaging, if that's the one thing that you want to do. So we're going to talk about the programs in the middle. Next slide. Yeah, so what is different or unique about the USC data science programs? One is that they're not just designed for computer science students. So if your background is engineering or statistics and mathematics or anything that has data-rich problems, then they are designed to be accessible to you. All these degrees are designed to be accessible to you. So we cover a lot of grounds to bring you up to speed in computing. The students that take our degrees are required to have some basic math background, but they're not required to have any computing or programming background. We basically bring you up to speed through the required courses. That's very unique to USC. And then the second thing that's very unique to USC is that we cover all areas of data science, of course, but we really emphasize the new computing innovations behind the data science revolution. So the foundations of computing and mostly AI and machine learning and also scalable data systems. So this makes USC very unique. What do data scientists do? These are pictures of the faces of some of our graduates. They understand the data technologies, but they also understand how to work in teams. We have a lot of project-based work in our courses. You understand how to connect computer science skills with data from different disciplines. Who else understands different parts of the problem in your team? Because there's not a single person in data science that will understand everything. So we learn to work with others to solve problems, given that everybody has different skills. Bridging expertise when there's not enough knowledge in a team, collaborating, learning from each other, the ethical and responsible use of data, and also being able to communicate effectively your skills, your work, and your findings. We have a very strong data science community at USC, so that is a picture of one of our events. One is our computer science led but campus-wide data science student organization. So they offer tutorials, they offer invited talks. There was a fantastic talk last week on ethical use of data and fair algorithms. And then they also hold a lot of one-on-one office hours. So if you get stuck doing homework or if you need help using a particular technology, there's a very nice support system for you on campus. We also have a Center for Knowledge-Powered Interdisciplinary Data Science, and this center holds semester-long data science projects that the faculty proposes and students volunteer to work on them. And they're usually pods of 4 or 5 students working on these projects for a semester where the students learn a lot. They do a final presentation, and we give awards to the best collaborating team, the best ideas, the best implementations, and so on and so forth. I want to show this because it's from a very popular data science website, and it shows where do big tech companies hire graduates from. So you see University of Washington, of course, everybody goes to the local Microsoft and Amazon. Berkeley and Stanford are in the middle of Silicon Valley. A lot of people going to Google and similar. UT Austin has a lot of local industry, for example, Dell Computers and so on. USC, we don't have a huge local big tech industry. We have a lot of entertainment-like companies headquartered in Los Angeles, like YouTube and Snapchat, but we are the 5th most hired place by the big tech that are in Seattle or the Bay Area. So I think that USC gives you a very good platform to good careers in tech. What we're going to talk about today is first the Master's in Applied Data Science. Then I will walk through these 5 interdisciplinary programs. If you have a passion for some of these areas, some of our students, for example, are very passionate about environmental problems or healthcare. So you'll see how we address specific types of data science. And then we'll talk about the Master of Science in Cybersecurity Engineering. So Applied Data Science is a master's program within the Department of Computer Science, like all of our data science degrees that I'm discussing today. And anyone with any kind of background, you don't have to have a CS undergraduate or programming skills, can come to this program. So if you have a computer science background, you have 3 required courses on data systems, machine learning, and data mining. But if you do not have a computing background, then you take 3 courses that count towards your electives, but they introduce you to programming, computing, and also data systems. And these courses are really designed for you. You're not going to be sitting in class with the computer science undergraduates. You're going to be sitting in class with people like yourself who may have some limited programming skills or some very good skills in terms of using computing or developing websites, but may not have as much computing background as we would need to do data science. A lot of these courses are offered through the Distance Education Network, the DEN programs at USC. And then for this program, you take 5 electives, and you can see some of the electives here, some of them on security and privacy, very important. Others have more to do with visualization or user interaction design. Others have more to do with web data. So you get a choice and range of electives. I'm going to move on to the interdisciplinary data science programs. In these programs, there's 5 of them, and all of them have the same common requirements. The programs were designed jointly by computer science, the data science group, and other schools at USC. So you get an education from both sides. The students that come to these programs either have expertise in the domain area, so say environmental sciences, or they have computer science background and they really want to get into these domains. Our core requirements are the same as you saw in the Applied Data Science program. There are 3 basic courses to learn computing, programming, and data systems. And then there's also electives on the computing side. Every one of these programs has also core requirements in that discipline and then electives in that particular discipline. So in communication data science, this is joined with the Annenberg School of Communications at USC. And you can see at the bottom that the data science pieces that we teach and the electives are the kinds of things that we've been talking about. But on the communication side, you will learn much more deeply about the theories and the models for human communication using technology, the technology platforms that we use for communication, and also how to affect behaviors and dynamic social interactions through communication technology. So this is a fancy way to say things like advertising or disseminating information. Spatial data science focuses very much on spatial computing. So if this is the kind of data that you're interested in, it's a really great program. It's together with the Dornside College Spatial Sciences Institute. And so the data science topics are the same we've been talking about, but the spatial skills that you learn have to do with geographic information systems, spatial decision support and problem solving, and then spatial databases and spatial data analysis that have their own formats, standards, and algorithms. In environmental data science, the focus on the environmental courses, which are, again, a half of your courses that you will take. There's some core environmental requirements and some electives in environmental studies. And so what you learn from the environmental side is how to analyze earth and environmental sciences. The data comes from sensors, satellites, all sorts of sources. How do you analyze that kind of data at scale? Also environmental risk analysis. What are potential interventions that you can do to treat water, to pump water from wells? What are the different trade-offs that you have, and what are the risks of running out of water, for example? And then environmental law and policy. a lot of companies are interested in environmental data science graduates. Sorry, just a thought that came to mind. In public policy data science, this is a new degree also as environmental data science is, and it very much focuses on public policy. So if you're interested in government, nonprofits, this is a great program. On the public policy courses, you will learn how to do data analysis for government in a way where you're really making it reproducible, explainable, accountable. You understand what data is used, the context, and so on. The institutional and legal challenges of collecting data from citizens, their rights and the responsibilities of the agencies that collect this data, and then how to incorporate data science processes and tools in a context of a government agency or public policy body. Healthcare data science, as you can imagine, has healthcare core requirements and electives. And what I want to highlight here is that we're thinking about students that want to join maybe major healthcare provider companies, but also startups in the biomedical area, in the health area. We talk about health and mental and behavioral health. So this includes how do you manage and process data to improve healthcare, clinical research and translational medicine. A lot of students interested in analyzing research data, biomedical data, personal devices, mobile apps for health. They require special treatment as far as data science, and also improving the healthcare delivery process. And I'll pass it on to Cliff to talk about this other program.
Okay, thank you. If we can go to the next slide, please. Okay, so I'm going to talk about the Master of Science in Cybersecurity Engineering. And any one of you that has listened to the news recently understands that on a weekly basis, almost a daily basis, we're hearing about implications of cybersecurity, whether it's the latest data breach, whether it's the latest ransomware attack, whether it is attacks on election infrastructure. And I've been involved in a lot having to do with cybersecurity for elections recently. And naturally, with all this concern that we've got out there, there's really been a brain drain. We need a lot more practitioners in this area. We need a lot more individuals with skills in this area if we're going to have a safe cyber realm. So that was the reason for creating this particular program. This program focuses on a couple of things. It focuses on fundamental theory and practice for engineering and operating secure information systems. So we have a focus on really sort of high assurance systems. But what we try to do is we try to apply it to the kinds of systems that we're using every day, whether we're talking about cloud-based systems, whether we're talking about mobile systems, systems that inherently have problems for security because the customers are demanding instant access to all their data all the time from wherever they might be. And you give them that access, and inevitably it creates access for the adversary as well. We want to sort of combine these two realms, the fundamental practice of information security with the kinds of systems that we're using more and more today. The program addresses challenges in terms of policy from a technical level, that is how systems enforce the controls on what is allowed and what is not. We're concerned with verifiably secure operating systems, and we have a whole class in the area of system assurance, which is designed to help us understand how to make the existing applications that we are deploying in the cloud environments more securable. We're concerned about applications and security awareness. That is, being aware of the kinds of threats that occur to these systems and how to defend against those threats. Of course, we apply the fundamental skills of security, including cryptography, in order to protect data. We apply this in both high assurance environments and also in the more available environments that we're using today. And we look at, again, the highly distributed cloud, network, and mobile-based applications as well. So that's sort of the overview. Now, you did jump to the slide, correct? I was making the transition. So here are some of the classes that we offer in this particular area. We start with our computer security systems class. This is focused really on the network, cloud environments, the kinds of environments that we're using on a daily basis. Concurrently with that, you will probably take Data Science 519. That's the foundations and policy for information security that is applied really towards the theory of the practice in high assurance systems. And what we want to do is we want to form sort of the joint domain between those two so that you can understand how to apply those underlying principles in the kinds of systems that are actually usable. We have our class on assurance, which helps you understand how a particular application, how a particular device, how a particular system of systems, including cyber-physical systems, including cell phones, including election systems for that matter, provides you with the sense that they are secure and the ability to look back on them and understand whether they operated in a safe manner. We also have a class on security, privacy, and policy, which is focused very much on, well, we have a number of topics. We have a high-level overview of the technical foundations, but we also cover privacy roles, things like GDPR and Europe's data protection regulations, California's CCPA, and next year we may have our Prop 24 to discuss. Actually, I've already been discussing that in terms of privacy in sort of the internet as a whole. 529 is a class that we have a lot of students coming from outside the School of Engineering to take because it is so applicable in the kinds of things that people are doing today. Now we have some electives. So you need to take those 4 classes. We have electives in applied cryptography for those that are more technically inclined, sort of not just technically, but more formally inclined. Trusted system design, analysis, and development for those that will be going out and developing large systems. Secure system administration, how to protect their networks. And then for those that are interested on sort of the back end, analyzing attacks that occurred, analyzing computer systems that have been under attack, we have a computer forensics class. We also have the opportunity to take some additional classes in very specific problem domains. We have a number of students that come from the oil industry that take our class in cybersecurity for oil and gas operations. We also have a class, Innovation for Defense Applications, where we have a number of students that work on real projects that have been curated by the defense industry and intelligence agencies, and you get to work on these with problem sponsors in those domains. We have a number of other classes that are available as well. And if you have something in your particular sort of external domain, remember Professor Gill was talking about how data science tries to blend the application areas with the foundational computer science areas. Well, if you're working in one of those application areas, we can actually work with you to find a class that fits into that area that also has elements of cybersecurity so that you can combine these aspects. Now, it's important to note that all of our classes are available through the Distance Education Network, and you're going to hear more about that later, but this makes them particularly suitable for students that might actually be employed, especially we've got a large number of students in the defense industries that are taking our cybersecurity engineering class. We've got a number in other industries. I already told you about oil and gas, but the DEN program makes these particularly suited for students that are currently employed, who might want to take maybe 1 class a semester instead of 2, or for that matter, even those that do want to take the full load of 2 per semester. But this provides an opportunity to maintain your employment while working on a degree that will be highly relevant in the field that you're operating. So with that, I'm going to pass it back, and I'll be available for questions later.
Great. Thank you so much, Professor Newman and Professor Gill, for providing that overview and additional information on the degree programs. I'm going to quickly just speak to some of the more logistical aspects of getting started as a student at USC Viterbi. I'm going to try to get through this pretty quickly because I really do want to focus on the questions that are coming through from all of you attending today. So in terms of admission criteria, the one thing I will mention specifically here is that all programs have unique application criteria, so you can visit the website provided here on the slide to identify your program of interest and the application criteria that is of specific interest, of specific requirements to your degree program. In general, our programs do require an undergraduate degree in engineering, math, or hard science from a regionally accredited university. You do need to provide official transcripts upon submission of your application. At this time, you just need to provide a copy of your transcript. It does not need to be officially sent from your university until you have been admitted. We are looking generally for a cumulative undergraduate GPA of at least a 3.0 on a 4.0 scale is recommended, but not required. One important update I do have for those of you looking to apply in the upcoming terms, the GRE is not going to be required for individuals applying to summer and fall 2021 applications to the Viterbi School of Engineering, due to a number of the challenges that we see our applicants facing during the times today. So that is something to keep in mind. Again, the GRE will not be required if you are looking to apply to these programs through fall 2021. I will note, if you are applying after that, you will need to check back in with us to see the current status of the GRE requirement at that time. A CV and resume is also required, as are supplemental materials like letters of recommendation. A statement of purpose is also going to be a required portion of your application. And for international applicants, an English language exam will also be required for your application. Now, I've listed some upcoming application deadlines for 2021, 2022. The spring 2021 application deadline. Now, this has passed September 15th. The reason I include it here, though, is because we do have an application deadline extension for those individuals that are interested in applying to pursue the program online via Done at Viterbi. If that is the case, you still have until November 15th to submit your application. Again, that is for individuals intending to pursue the entirety of their degree program online via Done at Viterbi. Now, for fall 2021, the application deadline is coming up. The final deadline is January 15th, although those applying to pursue the program online, again, we do have a bit more flexibility with your application. There is a separate scholarship application for those of you intending to pursue the program on USU's campus and are looking to be eligible for scholarship consideration. That deadline is December 15th. And then we've also listed the corresponding dates for spring of 2022. So we seem to have lost Professor Gill. So I'm actually going to continue on. I'll come back to this question here. Oh, there she is. There we go. But we'll start with you, Professor Newman. Would you be able to expand a little bit more on where your if you have current working professionals in your program, what are they currently doing as they pursue their degree program? And where do you see your graduates going after completion of their degree program, the types of industries and specific job opportunities that are available to them?
So we have students from a range of disciplines that are currently working, that are taking our cybersecurity engineering program. Among these, we've got maybe a fairly large segment from defense contractors, where they're currently employed by the defense contractors, and the contractors are paying for them to take the cybersecurity classes and pursue their degree. We have a few students in the entertainment industry, and in fact, some of our students that don't start out in that industry end up taking positions in some of the content creation industries around LA. Another area where we have quite a number of students that end up taking positions, that is after they complete our program, is in the cybersecurity consulting organizations that are hired to go in on engagements to various other organizations. And we've had a few of our students that have gone into some of the major cloud providers. I had one student that became a cybersecurity engineer at Amazon Web Services, for example, and quite a number that go into the high-tech sector. We also have a large contingent of our existing working students that are paid by various oil, in the oil industry. And that's one of the reasons that we had the petroleum engineering class as part of the curriculum, because that's highly relevant to the things that they're doing. So there's quite a range of where they go, quite a range of where they're actually employed. We've got several that are active duty military as well, sometimes taking it through DEN, sometimes that come here to take classes as well.
Thank you, Professor Newman. Same question to you, Professor Gill. Where do you see your data science graduates moving into in terms of careers upon completion of the program, different industries, different types of careers they can pursue?
Thank you. I'm sorry I got disconnected for a bit. So where do we see our graduates go? For the applied data science program, a lot of them go to the big tech companies. So Google, Microsoft, Amazon is very popular. So the big tech companies are probably where most of them are geared to go. For our interdisciplinary programs, it depends. The most long-standing programs that started in 2015 and 2016 are spatial data science and communication data science. So in spatial data science, we see our graduates going to Esri, which is the developer of ArcGIS and very powerful GIS tools. Esri, big tech company on spatial data science, also government. And then others go work for the big tech companies. And then in communication data science, it's very interesting because these are students that have both the communication, marketing, journalism kind of skills and the data science skills. And so they go on to places like, I can say Apple, Warner Brothers, companies that have to do with entertainment or advertising and so on. And they are best positioned to become managers of a team that has both programmers and marketing people and data science people. And so they understand all of the sides. And so they're very successful and they end up pretty quickly managing these teams and running projects and directing how the team does projects. So I think they are very successful at learning computing skills when they started with nothing. So in 2 years, I see them really having very, very solid computing skills. And I see them go and take positions of certain leadership that I'm very proud of, even in a short time.
Thank you. I think that really helps everyone get an understanding of the types of opportunities that become available to them. So I'm quickly going to go into our online delivery option that is available to those of you looking to pursue the program entirely online. So I do know right now all of us are online. So just to clarify the following information, let's just say we're back in normal time. There is 2 delivery options that are available to our students. The first is our traditional on-campus delivery option. This is generally pursued by full-time students that are taking around 2 classes per semester and are completing their degree program in about 1.5 years to 2 years. Now, and by the way, when I mentioned 2 classes, the data science courses and cybersecurity engineering courses are 4 units in length. So you're taking 8 units as a full-time student, just to clarify, because we do also have 3-unit courses available within the Viterbi School, so we sometimes get questions on that. Now, in terms of online delivery, this is the second option, and it's generally pursued by individuals that are pursuing a full-time employment as well as their degree program. So that generally means they're taking around one class a semester. Sometimes near the end of the program, they can add that second class in, and are taking about 2.5 to 3 years to complete their degree program. Now, how the Dennett Viterbi delivery option works. USC Viterbi utilizes a state-of-the-art proprietary web-based delivery system that enables students from around the world to access classes live or on demand. So what does that mean? That essentially means that as a Dennett Viterbi or online student, you are enrolled in and taking the same classes as your on-campus counterparts. You're viewing the same lectures, you are participating in the same classes. You have the opportunity to log in live if the class is being as a live learner via WebEx or Zoom, where you can call in and ask questions and participate interactively. You also have access to the archived version of the lecture, so a few minutes after the lecture is completed, that recording is then available for you to view in the evenings or on the weekends when it may best fit with your work schedule. But you are on the same calendar as your on-campus counterparts, so homework is submitted electronically. Exams are done at proctored testing centers near your home or office. Again, this is all when we're back to normal times. Right now, exams are done for everyone online. And if you happen to live in the greater Los Angeles area, you would come to USC for your examinations. This is a quick overview of some of the similarities and differences between our on-campus and online learners, Dennett Viterbi. The few things I want to point out here are that program admission requirements are exactly the same. You apply to the degree program, not a delivery method. So you go through the same application and are required to submit the same materials. And then ultimately the degree that you receive is going to be the same. It does not indicate online on that degree program. And the reason for that is because you are being held to the same criteria, the same requirements as your on-campus counterparts. You're just able to complete the program from a distance. So this snapshot was taken obviously before last spring, where we have our on-campus student population. In the back of every classroom is our camera operator. This is the individual that is capturing everything that's happening within the classroom setting so that you as an online student are able to participate and obtain all the information that's being provided to your on-campus counterparts. This is some additional information here for the Dennett Viterbi learner. I won't go through all of it in detail because I want to get over to those questions. But one thing I will mention is if you are eligible, you may be able to enroll in limited status enrollment. That would enable you to begin taking classes in these great programs that we've been discussing today. As early as spring 2021, you do have to meet specific criteria for limited enrollment, but there is still time to be approved and register for classes for spring 2021 if you don't think you can get your application submitted in time. Additionally, if you are receiving tuition assistance from your employer, there is the Employer Reimbursement Deferment Program, which helps to avoid significant out-of-pocket expenses on your end. The following is an overview of our tuition and fees, or tuition costs, for the fall 2020 to summer 2021 academic year. The cost, regardless of your delivery method, is going to be per unit $2,148. As I mentioned earlier, your courses will be mostly 4-unit courses, which means they'll come out to $8,592 per course. Additional fee structures can be reviewed by visiting the link provided. We do have a number of scholarship opportunities, so I do encourage you to visit our website for more information on those opportunities that are available to you, whether you're pursuing the program on USC's campus or online via Dennett Viterbi. Now, again, I'll be sending out these slides so that you can review these next steps in more detail. I will leave the slide up on this contact us section in case we don't get to your question. You can make sure to email that over to us and we can address it directly. But I'm going to go ahead and jump right in to some of these questions. The first question for Professor Gill, I will ask, because we've actually had it asked a couple of times here, is can you explain the difference or why a student would want to pursue the MS in Applied Data Science versus the MS in Computer Science with a focus in data science? I know you touched on it briefly in your presentation, but if you wouldn't mind expanding on that just a little bit more, as we did get a couple questions about that.
That's a very, very good question. So the students that sign up for the computer science master's degree with a concentration on data science, they get a little bit of electives on data science classes, mostly focused on machine learning and algorithms. There's a lot of classes that we offer in the data science program that are not available to those students in computer science. And that includes things like user interaction design, the visualization classes, and other classes that have more to do with data mining and data systems. There's also classes that we offer in data science that are practicums. So this means that it's a class where you will be given data sets from real world problems, and you will form teams with your classmates to work on projects to solve that problem. And there will be 2 or 3 groups in total in the class. And so you learn to develop solutions as a team. So it's a very practical minded kind of class that gives you real world exposure to data science. So I think if you're looking for more algorithmic and computing skills to develop new data science algorithms, then the master's in computer science is appropriate. If you're looking more for actually analyzing data, understanding the tools and techniques for data science, and developing practical data skills, then I think the applied data science program is more appropriate.
Perfect. Professor Newman, I will ask this question of you, and I will read it directly because it has a lot of enthusiasm. Hi, Professor Newman. The MS in cybersecurity engineering seems incredibly interesting and fun. I am also really excited you touched on CCPA and privacy, as well as the technical classes such as applied cryptography. So I see, Professor Newman, you did apply to it, but reply to it directly. But would you mind just kind of expanding a little bit on those subject areas that you did touch on directly, and how they are incorporated into the program?
Okay, well, one of the things that's very important is, in data science in general, and certainly in terms of security, is the impact that these fields have on society as a whole. And in fact, we're hearing lots of things about the problems of data science in terms of what it's able to learn about our interests and how it's able to target us and manipulate us. And we've got a lot of discussions of influence of social media. Now, it's very important not just for the cybersecurity engineering students, but also for the other data science students that are going to be developing the tools that have the potential to do harm as well as the potential to do good. It's important that they understand what the potential implications are so that they can design their systems and sort of rein in certain kinds of activities that might push that across that boundary. So that's why we talk about these. That's why Data Science 529 is one of the electives in many of the other data science programs, not just in the cybersecurity engineering program. Now, some of the kinds of things we're talking about this year, well, we're talking about influence on elections. We're talking about the impact of cyber physical systems, or Internet of Things devices, and all the problems that occur because of that, and how to defend these kinds of systems to make them less vulnerable to the hacks that are coming into people's homes through these devices. So, you pick up any of the sensationalized news about computers, and these are smack in the middle of the issues that we're talking about. Now, the solutions to these problems are not always entirely technical. We give you the foundations to understand what can be solved technically and how to apply those solutions technically, but sometimes there are policy decisions that need to be made in the form of public policy as well. So one of the goals of this particular program is not just to educate the technologists, but to educate the non-technologists on the technology, so that when they go back trying to set public policy, they know what's possible, they know what the implications of what's possible is, and they can make sound judgments in those other areas.
So this next question I'll direct to Professor Gill, and then I'll ask a similar question of you, Professor Newman, because I think we have a couple of questions that kind of touch on the admission requirements and what you're looking for in terms of a successful applicant to the program. Now, this specific question is about the Applied Data Science program and what you're looking for in terms of individuals that are coming from a non-engineering or science background, and if there are additional aspects to their application that they should, in terms of academic maybe aspects that they should have to enhance their admission to the admissibility to the program.
That's a very good question. Really the requirement is that you have taken basic math classes in college so that you can tackle the mathematical and algorithmic sides of the curriculum. So we don't require computing, but we do require that you have taken some classes. So for example, if you've taken some calculus class, or maybe some probability theory class, any of those would be valid. There's more information on the website if you have specific questions about the type of class that would count or not count.
Perfect. And Professor Newman, a question to you also on admissibility, but in this case, the individual is asking if work experience factors in, if they are looking if having a related internship or specific certifications would enhance their admissibility.
Yes, so work experience absolutely does. And sort of the way things usually happen is, you've got one set of students that clearly match what we're looking for. And those that don't clearly match that, I usually get an inquiry from the admissions department. And I look at that to see whether I believe that the student has the background that is necessary to do well in our programs. And in order to do that, oftentimes we find students that have maybe not as much background in pure computer science, maybe not a computer science degree, for example, but because they've been in the military, have been working on IT and certifications from various defense universities for some of the things they've been doing in that area, or because their job position has involved them working with computers and operating systems and networks. I'm able to look at that and see, okay, yes, they do have the background that is going to allow them to do well in our program. In some other cases, part of it is looking at sort of the statement of interest and seeing which area they're trying to get into. So if we had someone that was more of a background in, let's say, public policy, for example, their interests were going into that area, we then figure out what might be possible sort of in terms of remediation so that we can admit them to the program, but make sure that they acquire the background that is necessary in order for them to excel.
Thank you. So I think we have time, or I'm going to be pushing it, but we'll have time for one additional question. The question I think I'd like to ask here, because it was asked a couple of different ways, but for both of you, in terms of your corresponding degree programs, would you be able to expand a little bit more on the experience students may have within those degree programs in terms of hands-on projects that might be part of that curriculum that they'll be exposed to while a student, whether online or on USC's campus?
Go ahead, Cliff.
Okay, sure. So a couple of things that are hands-on. First of all, within our Computer Science 530 class, that's the one that focuses on network, mobile system security, and basic security technologies. We have a bunch of labs where the students get to apply many of the tools, as well as some tools that are designed to highlight what the problems of the system are as well. In other words, some hacking tools as well that they get to apply. In our Secure System Administration class, we have students develop sort of toy systems which they then need to defend, but that are deployed in the cloud so that they can try the particular tools and see how they hold up against other students in the class as well. So that gives them a little bit of hands-on. Now, another course which we've got, it's not actually explicitly listed in the list of classes, but we have encouraged students to take this class, and we've got quite a number that do go through it. is our Innovation for Defense Applications class. And in this one, teams of students, actually cross-disciplinary teams, because we try to form the teams. So you'll have a student maybe in the data science program, maybe one in CS, maybe someone from the business school, maybe someone from another school as well, that come together and work on problems that are curated and presented to us by various defense agencies and intelligence agencies. And you go through the entire semester working on the one project that has been provided to your team. And you develop reports and presentations, and you develop what we call a minimum viable product, a prototype in essence, to demonstrate solutions to that problem. Now, a lot of this class is really on the problem discovery. That is how to understand what the real problem is. But then once you've gotten through that, you go and you create a prototype, and this gives you experience working in teams on real problems.
So for the data science side, I mentioned that our Center for Data Science has a lot of semester-long projects where you can volunteer to work with other students on projects that are proposed by the faculty. So these range, they really cover every area. There's been projects on from faculty in the social work side, games, data from games that faculty have access to that are really hard to access, that they make available to the students volunteering to work on this. Local non-profits in LA working on health that provide data to the faculty, and so the students get involved with those. So there's a range of semester-long projects that you can participate on. More formally, I mentioned that we have a practicum course that you can take as an elective, where you would work with other students, and there's 3 or 4 groups, basically each developing a different solution independently. And you learn from what your own group is doing and from working with your own group, but also from the alternative solutions that the other groups are developing. So yes, there's a lot of opportunities to do that. In the classes for data science, we are very mindful of helping you develop a curriculum. So we have in every class, the class projects tend to have enough substance and not just be small homeworks, but really have enough substance that you can talk about them and describe them in your CV as a substantial experience in data science. So we're very mindful of how important it is to have this practical experience while you are at USC.
Perfect. Well, I think that's a great way to end this session. I know there are more questions out there, and we will try to get to all of those via the chat function. To Professor Gill and Professor Newman, thank you so much for taking the time today to talk about the programs in more detail and share information. I think this was really valuable to all those individuals that are able to learn a little bit more about programs they have an interest in. And for those of you out there that are attending today's or watching the recording, I do encourage you to reach out to us via email with any additional questions that you may have throughout the process, or as you consider applying to the degree programs. We're always happy to have additional conversations with you and help walk you through the process as well. So thanks to everyone for joining us today, and I hope you all have a wonderful rest of your day. Thank you so much.